Hey everybody, thanks so much for coming to this talk about operationalizing Serve on Kubernetes. First, I want to talk a little bit about ourselves. My name is Shreyas. I'm a software engineer at Anyscale.
Yeah, I'm Bruce. I'm also a software engineer at Anyscale.
Yeah, Bruce and I both work on Serve at Anyscale. Now, before we talk about how we operationalize Serve on Kubernetes, let's talk a little bit about Serve at a higher level. What exactly is Serve and what does it do? Serve is a flexible, scalable, and efficient compute engine for online inference. It runs on top of Ray, which provides scalability, low latency, and efficiency. It has first-class support for multi-model inference. We're introducing a new deployment graph API in Ray 2.0 that lets you compose lots of different models together in order to serve requests. And last but not least, it's Python native. It has a really simple API that makes it very easy for you to mix arbitrary business logic with model inference. This talk is going to be all about how Serve 2.0 is production ready. In Serve 2.0, we're introducing a new dev-to-prod experience that makes it really easy to do config management by centralizing all of your config information in a single YAML file. Serve 2.0 is also going to offer a new Serve CLI that makes it really easy for you to iterate on your Serve application and then deploy it to production. And last but not least, we're providing native integration between Serve and Kubernetes. So you get all the benefits of Serve, including the simple API, the efficient compute, and the scalability, as well as all the cluster management features that Kubernetes provides. This enables a whole lot of great new features, including enhanced observability, blue-green deployment, zero downtime upgrades, and more. This talk is going to be all about this new dev-to-prod experience in Serve. We're going to touch a little bit on MLOps in general, and then we're going to discuss this new dev-to-prod workflow in Serve, and then we're going to wrap up by talking about the native integration between Serve and Kubernetes. With that, let's jump into a little bit of background information about MLOps in general. So when I say MLOps, what exactly am I talking about? There's a lot of good definitions for MLOps in industry and academia, but for the purposes of this talk, when I say MLOps, I'm talking about practices to deploy, manage, and monitor your machine learning models. There's a lot of tools to help you do this. These tools can help you with model serving, model training, data preparation, model validation, and more. These provide lots of different benefits, but there's three of them that I want to highlight for this talk. First is that MLOps really helps improve your dev-to-prod workflow because it makes it really easy for you to develop your application locally and then deploy it to production. It enables and expedites your CI/CD pipelines, so you can iterate quickly and update your application to best serve your users. And in addition to all of this, there's a whole ecosystem of support infrastructure that you can pick and choose from to tailor your MLOps infrastructure to best suit your application. Now let's dive a little deeper into Serve 2.0 and talk about how the new dev-to-prod workflow helps deliver a lot of these MLOps benefits for your application. In Serve 1.0 and in Serve 2.0, you can define your config in Python. In Serve 1.0, we saw that you could define configure information like the number of replicas, your auto-scaling parameters, your runtime environment information, maximum concurrent queries, and more inside of the deployment decorator. You can continue to do this in Serve 2.0, and it's a really useful way for you to iterate on your application during development, because you can tweak these parameters directly in Python and find what works best for your application. In 2.0, we're also adding a centralized config in YAML. This config contains all of the same information as the decorator. But because we've consolidated all of this config information in a single YAML file, Serve 2.0 provides some new operational advantages for your application. This centralized config enables, first, a smooth dev-to-prod workflow. As we'll soon see in the talk, you are able to first develop your Serve application and then auto-generate this config file. Then you can simply apply that config file to your Ray cluster, and then you're on your way. Your deployments are live in production, and they can serve user traffic. Second, this new Serve API provides a CLI that lets you really quickly iterate on your Serve application and then deploy it to production. And last, we're going to talk a little bit about a native Kubernetes integration that's enabled by that centralized config. Now, let's dive a little bit deeper into that dev-to-prod workflow. The first step in any workflow from getting to development to production is to actually develop the application. So once the developers are finished developing an application, they're going to try to deploy it to production. With this new centralized config file, the users can first auto-generate a config from their RayServe application. This auto-generation step only requires a single CLI command. And then after that, they can use a separate CLI command to deploy their application to production. At this point in the process, the deployments are live in production, and they can start serving user traffic. The last step in this dev to prod workflow is to issue updates. So let's say that you're monitoring traffic and you see that there's a spike, and you want to increase the number of replicas in your deployment to serve that update in traffic. You can simply bump the number of replicas inside of that config file and reapply it to your cluster. And then Serve will automatically spin up new replicas for your deployment and continue to serve traffic. This completes the loop in the dev to prod workflow because you've gone from development to production, and now you can continuously monitor and manage your deployments in production. We're really trying to bring you the best of both worlds in 2.0. We want to make it really easy for you to do development, where you're going to be doing a lot of quick updates and a lot of manual iteration. At this point in the process, you're going to be interfacing mostly with the Python API in RayServe, where you're changing everything in Python, you're quickly running your application, and you're checking for correctness. In production, you're going to be interfacing more with that YAML file. You'll be able to make a lot of consistent, stable updates simply by tweaking parameters in that YAML file and then applying it to your cluster. In addition to this, because we've centralized all of this information in a single file, RayServe 2.0 is really automation friendly. You can plug in this config file into your own custom CI/CD pipelines, automation tooling, so on and so forth, in order to automatically manage your RayServe cluster. I've alluded to a RayServe CLI a couple of times, so let's dig a little deeper into the CLI commands that we offer in 2.0. These commands can be divided into two categories. First, we have our dev to prod commands. These are the commands that enable that dev to prod workflow I was talking about before. And then we have monitoring commands. The three dev to prod commands that we've added are serve run, serve build, and serve deploy. We'll go a little bit deeper in detail on this in just a little bit. The next set of commands, the monitoring commands, let you review the status of your serve application in production. So the first command, serve status, will tell you whether your deployments are healthy, unhealthy. It'll give you debugging information, and it'll let you know what the progress of any in-progress update is for all of your deployments. The second command, serve config, gives you information about the current config in your Ray cluster. This will tell you exactly what the target state of your serve application is, and it'll give you information on how you can update it. Now, let's take a closer look at the dev to prod commands. The first dev to prod command is serve run. This is the command that you're going to be using when you're still doing development for your RayServe application. In order to use this command, we first author a serve deployment, just like we did in Serve 1.0. Then we can open up a command prompt and run serve run, and then pass in the import path to our serve application. In this example, that import path is my server, which comes from the file name, and then graph, which comes from the application stored on line 9 in the code. At this point, the serve run command will launch a Ray cluster locally, and then deploy your deployments to that cluster. After that, you can open a separate command prompt window and send HTTP requests to that deployment to test out its behavior and check for any bugs and make sure that everything is working correctly. After you've gone through this loop of iteration using serve run, the next step is to build your config file. Serve build lets you, again, provide your application code. In this case, this code example is the same as the last slide, except we've tweaked some of the config parameters, and there might have been some updates to that model server code. You can run serve build, and you can pass in the import path from the serve run command. And then in addition to that, you pass in a config file that you want to write this config information to. Serve build will take a look at your RayServe application, and it'll auto-generate a config file. After this, we can actually deploy that config file to our Ray cluster using the serve deploy command. In this diagram on the left, we have our laptop, which contains the config file for our serve application. And on the right, we have the production Ray cluster, where we actually want to deploy our deployments to. We can run serve deploy and then pass in the config file. And this, as we can see in the command prompt, says that we've sent a deploy request successfully. What's happening behind the scenes is that the laptop is making a connection to the Ray cluster, and it's sending the data from the config file over a REST request. The Ray cluster is going to grab that config file and store it, and then it's going to launch a serve application and deploy the deployments for that application using the data from that config file. At this point, your application is live in production. If you want to make updates to it, you can simply update that config file and redeploy it using serve deploy. As we can see, this is a really easy workflow to get from development all the way to deployment in order to actually serve your users in production. Now, One other really important feature of this config file is its ability to integrate with other tooling. And a great example of that is the new native integration between Serve 2.0 and Kubernetes. I'd like to hand it off now to Bruce, who's going to talk a little bit more about this integration.
Yep. Thanks for a great presentation that provided by Shreyas. So follow-up, I will talk about how we can use Kubernetes for your Serve application to do the from dev to product deployment and further the cluster management. So let's go to next slides. Based on the description of Shreyas, Service 2.0 actually provided the centralized config, which is YAML config, and that is natively integrated with Kubernetes because all the CR is actually config, also throw a YAML config in the Kubernetes. And let's see the architecture. So besides the Serve CLI that we just introduced, there is another component called Kubernetes operator, which can run your reserve in the production, which is based on the centralized YAML config. So next slide, let me give a brief introduction about Kubernetes. Actually, it's a very well-known open source platform, and it's mainly for managing the containerized workloads and services. In our case, let's say it's manage all the resources. So let's take a look. So the upper side is all the advantages that can be provided by Serve, like the simple model serving, intuitive model composition, and flexible scaling and the resource allocation. And combined with the Kubernetes, it helps you to manage, let's say, the cluster creation part, the cluster recovery part if anything failed. And then it also provides networking, routing, and the load balancing features, which are very good features. So I want to also introduce an open source project called Kubernetes. Kubernetes is actually a community project, and it's going to be the future, let's say, the official way to deploy resources on Kubernetes cluster. And let's see what Kubernetes provides to you. So Kubernetes actually can manage different kinds of resources. It includes cluster, job, and services. And each of them has their own operator to help you just manage them automatically. And because we are based on Kubernetes, we have all the advantage Kubernetes can provide. So you can just use kubectl to operate your CRD. It includes create, read, update, and delete. And also, if you install the Kubernetes dashboard, you will have a very beautiful, like say, monitoring dashboard, and also you do some management through it. So let's go to next slide. So let's say this presentation, we focus on how we manage Serve. So in that case, we have a service customer resource and its corresponding operator to manage Serve in Kubernetes cluster. So what does service operator provide? Now, first is Kubernetes native. So you can just deploy, update, and delete it through kubectl. It's very simple. And in our operator, we also enable the zero downtime upgrades for your Serve application. So when you do the upgrade, it will not down. It will still serving the production traffic. And we also, like say, leverage the Kubernetes recovery mechanism to offer HA property for your Serve application. So let's take a detailed look about, like say, how the Serve operator actually works. As Shreyas just present, your Serve application will have a centralized config, which is YAML config. And once you finish your development, you will have the YAML config. So the YAML config actually is a part of the spec config of Service CR. So let's say you put it into your Service CR, and you also define it, a recluster CR, recluster YAML config, also put in the CR. Then the Service operator will first read the recluster config and start a recluster. So recluster is another CR that developed by Kubernetes, and it has its own operator. So the recluster will read its own, like say, CR config, and then start the recluster in Kubernetes cluster. The Service operator will know this cluster and keep a health check to know, okay, whether this recluster is ready to deploy any server deployments. And once it found, okay, recluster is ready, it will read the centralized config of the server application, and through the REST API, we send it to the recluster. And then recluster will do deployment in it, and then we will have a server deployment ready. The service will also keep checking whether the server deployment is fully deployed and whether the application status is running. And once it's running, it will create a Kubernetes service, which, like say, provide you a way that you can route your production traffic to this server application. So as Shreyas just also mentioned, we can do in-place rolling upgrade for your server deployments. It's also very easy on Kubernetes. What you need to do is you go to your development, you generate a new centralized config for your Serve application. And then you can just update the reservice CR and do the apply again. Kubernetes will take it, and the operator will find, OK, this is a new Serve config. And will send through the REST API again, see that error again. And then in recluster, we will do in-place rolling upgrade for this Serve deployment. But what if you want to, say, have some bigger change? For example, the Ray just released a new version, so you want to update your Ray container to a new version of Ray. Then we cannot do in-place update within Ray cluster. So the Ray service cluster, Ray service operator provide you another way to do a very safe deployment, which we call blue-green deployment. So the Ray service will detect, OK, we have cluster config change. It will first start a green cluster, follow the same routine as the blue one. It will create a Ray cluster, and deploy the Serve deployments, and keep tracking the health status of it. And once this green Serve deployment is fully healthy and can serve production traffic, what we do is we will update the Kubernetes service to redirect the production traffic to the green one. And once it's fully done, we will terminate the blue cluster. So in that case, you see, we can in-place update your Serve deployment config. We can also update the recluster config. And then it's all zero downtime. Your production is still functioning, and there is no QPS drop. So besides the zero upgrade, and we also want to provide some furthermore feature to increase your SLA for your Reserve application. Another very major feature is the high availability. So there is another talk, Reserve HA, yesterday afternoon, which is session 222. And there is a lot of detail that how we do HA within Reserve. So in this presentation, we just how we use it in Kubernetes stack. So the Rehab node actually requires a Redis to do HA. So the Kubernetes will have a config that, OK, you can provide the Redis configuration to the Rehab node, and it will do all the logging for that Redis. And then Kubernetes provides readiness and liveness probe for head node. So whenever head node is unhealthy, the Kubernetes will try to restart it. The same as worker node, we will have readiness and liveness probe to check whether the worker node is functional or not. And then we will restart the worker node if it crashes. We have one level higher, which is the final guard of your SLA. The thing is, the reservice operator will keep checking whether this cluster is healthy or not. Or like say your Serve deployment, it can still serve your traffic or not. By checking those like say status and matrix, if we found something is wrong, it's not functional, we will try to create a new cluster, which is very similar to the green cluster you just see. And once the green cluster is ready and can serve production traffic, we will update the Kubernetes service to use the green cluster, new cluster, and then we will tear down the broken cluster. So in that way, we can recover in a very fast manner. So let's take a detailed look. OK, what is the CR look like and how we deploy it? So the left side is a CR definition, and the bottom part is what you have for your centralized config for your Reserve application. And the upper part is some metadata for Kubernetes usage. To deploy it is very simple. Just use kubectl apply with this YAML config. Kubernetes and the operator will handle everything for you. So let's say I already run my Serve application, my reservice in Kubernetes cluster. So how can I monitor it? How can I know, OK, what happened? We provide some observability endpoint for you. There are two methods. One is the Kubernetes native provided logging structure, logging endpoint. There are two things. One is kubectl logs and kubectl describe, for example. So here we have a screenshot. This screenshot shows you how you can use kubectl logs to get whatever logs for every kind of part that Kubernetes is running. So in this example, we see the head node log. So you just run these logs. You can just show the main line, which is, OK, runtime is started. So next exercise, we use kubectl describe to describe your reservice, which is the CR that we just create. And you can see there are two things we want to mention. One is the application status. You can see it's running. There also include a lot of details about your deployments within your whole application. So you can see a lot of detailed current status. Also, it includes another very important thing is the event log. So you can see in the example, we are waiting for the dashboard to be ready. We try to deploy the deployments, and we are waiting for that. And you can have all those events, and it's very easy for you to know what happened in the reservice application. Next slide is the second way you can do observability. So in RAID 2.0, we actually provide a lot of new status monitoring API, which you can see a lot of details of your RAID serve, your RAID cluster. And as just mentioned by Shreyas, we also have serve status and the serve config endpoints that you can see what happened for serve. So Kubernetes also provides a very natural way. You can use the exec command to send you command to whatever, like say, node that is currently running in Kubernetes. So in this example, we just send the RAID summary tasks command to the head node, and it will directly print the results in your terminal. So we can see, okay, how many actors right now is running, and you can use that to do observability and do the debug. Thanks, that's my part. So I will hand to Shreyas to do a summary.
Awesome, thanks, Bruce. Yeah, thanks for covering all of these awesome integrations with Kubernetes. So in summary, we talked a lot today about RayServe 2.0's new dev to prod experience. We showed you how you could simplify your config management with this centralized config file. We talked about the new Serve CLI that makes it really easy for you to go from development to production. And we wrapped it up by talking a lot about this native integration between RayServe and Kubernetes. As a reminder, this enables a whole lot of new great features that you can use with RayServe. With that, we just want to say thank you so much for listening, and we'd love to take some questions. All right. Are there questions in the audience? Oh, over here. Can you keep your hands raised if you have questions? Yeah. Yep. Go ahead.
I'm just wondering, can you use the Serve CLI and the Ray service operator together? Can you? Because it seems like for the Ray service operator, you have one YAML config file with all your deployments. Can you also deploy with the Serve CLI on top of that, or it's just one or the other?
Yeah, that's a good question. So the Serve CLI is more meant for when you're deploying your Ray Serve deployments to a Ray cluster that's not really running on Kubernetes. But when you are running on Kubernetes, there are Kubernetes commands, for example, like kubectl apply, that map to those Serve commands. So when you're running on Kubernetes, you still have CLI commands that you can use to deploy and manage your deployments.
A little more detail. Actually, when you run your Ray cluster in Kubernetes, the Serve CLI is not forbidden. But even if you run it, the Kubernetes operator will detect the current state. And if the current state does not match your CR definition, the operator will change it back. So you use the Serve CLI to update your server deployment, but Kubernetes already detected, so it will revert it back. So it's actually two stacks that how you can manage the serve application. Yeah.
Hi, a question about blue-green deployment. So
we go back to that.
If your blue-green deployment, when you create a new Ray cluster, if you run into resource provisioning problems, for example, not enough GPUs or there are some quota issues, do you have any plan ahead before you do blue-green upgrade?
Good question. So right now, blue-green deployment require you have, like say, double resources available so we can create the green cluster. But the worst thing is that, okay, when you do blue-green, deployment, and if you don't have enough resources, the green cluster will always fail, and then we will never switch to the green one. But you will view it in the event log, or you can just check the Kubernetes native log to know, or you can set up the matrix by yourself to get some alerts. So you know, okay, the green cluster never starts, but it will not influence your current blue cluster. So even though you have a failed upgrade, but that's fine. Your service will not be impacted. So you have enough time to fix it. Yeah, Thomas?
One in the back.
I have a follow-up question. So if you use the Ray service and you have this one config file, does that mean every time you want to deploy a new model, you have to add to that YAML file? And if so, how would you, what would you suggest for if I wanted to have an automated deployment pipeline?
Okay. So I think that's very native support. So either long-range like Python or Golang, they all have Kubernetes libraries. So what you need to do is you have you do your local development, and as Shreyas just present, you can convert it to the centralized config YAML config of your server deployment. And then, like say, your automation workflow can just fetch the new YAML file. Like say, it may detect the YAML file change, and it can just apply to the Kubernetes cluster. And Kubernetes provide a very good thing is all this, like say, operation is idempotent. It means even though, like say, your RAID service config does not change, you can still keep applying it. There is, like say, no, like say, side effect of that.
Over here.
Hello. I noticed that there's an autoscaler component of Ray as well. Can you elaborate on how that plays nicely or doesn't play nicely with the Kubernetes native autoscaler?
Yeah, that's a great question. So Ray Serve's autoscaling uses kind of like a layered approach. At the Ray Serve level, what we do is we autoscale based on the number of requests that are coming in. And this is once you set your autoscaling parameters to the minimum number of replicas you ever want and then the maximum number of replicas. So that autoscaler will either scale up or scale down. And what that means is when, for example, you want your Ray Serve deployment to scale up, Serve will request for new replicas to be scheduled on your Ray cluster. At that point, the Ray cluster's autoscaler will kick in and then communicate with Kubernetes to provision more resources if you need more resources in order to schedule that replica.
And some add-on to that. So actually for Kubernetes, we do not use the autoscale for, like say, the container part number for deployment. We just manage it by communicating with the autoscaler of Ray, right? So when we upscale, we get the requirement from Ray autoscaler. And when we downscale, we also get required from there. So in Kubernetes, we don't use like the Kubernetes automatically, like say, autoscaler. We just have a min worker count and a maximum worker count and make sure that the Ray autoscaler send the request that makes sense. Do not like say, have a conflict with our min and max worker.
Sorry, a follow-up question about the Ray autoscaler. So is it something that be able to configurable by users, or is the number of the scaling behavior based on number of requests is kind of a default setting that users cannot tune? Because for models are heterogeneous, right? They can be very different in terms of scaling behaviors.
Yeah, that's a good question. So at the Ray Serve level, when you're trying to autoscale based on the number of requests that are coming in, you're able to configure the minimum number of replicas, the maximum number of replicas, and you're able to scale based on, so you're able to set a target number of replicas that you want, a target number of requests that you want per replica. So if there's more requests than you want, then the Ray Serve will scale up. If there's fewer, it'll scale down. And in addition to those three parameters, we also expose some private parameters that you can also tune. So you can modify the auto-scaling behavior. Are there any other questions? One over there.
It's just a follow-up on the autoscaler. So did I understand right that the Ray autoscaler kind of only creates the pods, but the cluster autoscaler is responsible for checking if enough resources are available for these pods? So like ultimately, do we rely on Kubernetes scheduler to actually schedule them?
Oh, I don't need. So thanks for the question. So the Ray autoscaler will know, okay, whether I need a new, like say, a pod, like say I can deploy more, like say, server deployment actor there. And we'll tell the Kubernetes by updating the CR, right? And then the Kubernetes know, like say the Ray cluster operator will know, okay, now my request pod number increase. I need to try to schedule another pod, create another pod automatically by Kubernetes. And if we have enough resources, we will do that. But if it's already exceeded the config, the maximum worker node number, the Kubernetes will not take any action.
So it's not directly communicating with the autoscaler, it's relying on the Kubernetes autoscaler.
Yes.
Okay, got it.
Mm-hmm. Are there other questions? One over here.
Sorry, this will have to be the last question.
Sure, very quick one. I saw on the Kubernetes website that there's no documentation yet for Ray service. Do you know when that will be released?
We have documentation there. It's in some advanced feature tag, some other tag.
Yeah, we can help look for it
cool.
once we're finished up.
You find it?
No, I see it now. Thank you very much.
Awesome.
Okay, awesome.
Yeah. Any other questions? I think I saw some in the back.
They'll have to meet you at the
front. Oh, okay. All right. Yeah, I think we're out of time. Thank you so much for coming.
Thank you, everyone.